Thank you so much.
Yes, Smartika.
Yes, sir. Is it visible?
PPT is not visible. Your screen is visible.
Oh, just a second. Now?
Yeah, now your screen is visible.
Okay. So hello everyone. I'll be giving, as sir already introduced, that I'll be giving a talk on future in AI and ML and what you should be expecting and how you can prepare to have a career if you ever plan to. A quick like the background about who I am, although most of it sir has already covered. I did my graduation in electrical and electronics engineering department at NIT Hamirpur, and I passed out in 2014. Post which I worked at Nuclear Software Exports Limited, which is a financial company. So the internet banking softwares that you usually see in maybe when you log in ICICI or SBI. So that is what the company used to make. But post that, I felt that since I had developed a bit of interest in machine learning while I was doing my graduation, so why not just get more information and learn more about that field? So for that, I started looking for master's courses that are available. And the reason for giving GATE in CSE was mostly because at least at that time, I felt that in electrical and electronics department, the courses were less inclined towards specifically AI and ML. They were like only some courses were available and only in few departments, in few colleges it was available. So that was the reason that I gave GATE in computer science, and then I got admitted to IT Bombay. And after getting campus placed in Microsoft, I've been working there for the past 2 years. And so going forward, the topics that I'll be covering as part of this talk is one thing that what all AI and ML comprises of. So usually, at least when I was doing my bachelor's, then I was not very much familiar with what all actually comes under artificial intelligence, or what all are the fields areas that are available that you can do research in, or where you can work in an industry. Also, like what all are the skills that are needed that you should be maybe gathering, just so you become more efficient towards working on those models, or creating models of your own. And then like if you develop enough interest till the end of the presentation, then I'll give you a few pointers on how you can start off after this presentation, as to how or what all are the resources that you can just get started with. With that, I'll quickly give an overview of what exactly artificial intelligence comprises of. So as you can see that it's not just about machine learning or deep learning. So that has become a buzzword these days. So almost everybody gets excited with the words, with these words. But then those are just a small portion of artificial intelligence. There is like reward based learning, which is a reinforcement learning, or there is natural language processing that is part of artificial intelligence. things like translation or a sentiment analysis. Like few things I'll be covering in next slide 2 in depth, but like a lot of things come under this umbrella of artificial intelligence. So in order to achieve artificial intelligence, these are the tools that you can use, which could be machine learning, could be reward-based learning, and so on and so forth. So to give you more relatable examples of what I'm talking about or what these fields do internally. For example, if you take facial recognition, so when you use Google Photos, then Google automatically like tracks what all pictures are there and what all your friends are, and then club together those pictures for you to make the search easy for you. So that is a facial recognition running in the background on all the pictures that you have in your photo gallery or new pictures that you click. Similarly, if you take example of maybe speech recognition, so like when you interact with Siri or when you interact with Google Home, there is a speech recognition at work. When you say something, and even when it is not very proper, but still Siri understands what your intention was or what you actually wanted to ask. So those are some examples that would make you more relatable to what all speech recognition or facial recognition or deep learning does in background. Similarly, if you take example of autonomous cars, so that is even like IoT also at work in the background, not just artificial intelligence. So sensors, then sensors capturing whether the obstacle is at how far distance, whether it should apply brake on its own. So it's not purely intelligence or purely artificial intelligence at work, but it's a mix of a lot of things going on in the background that enable all these intelligent systems that we talk about these days. So moving forward to, also please feel free to ask any questions if you have, and interrupt me in the middle of the talk. Yeah, so moving on, what all machine learning comprises of. So machine learning, you can see that you can assume that it is divided into three subsections, one being supervised learning, one being unsupervised learning, and the other one being reinforcement learning. So supervised learning is usually when you have the data set as labeled, that is, you know what the input is and what you should be expecting out of. That would be supervised learning. Similarly, unsupervised learning is when you don't know what the output is, but somehow you want to either cluster things.
अभी आ रहा हूँ क्या वो तो बैग के लिए पूछ रहे थे लिए बैग भेज हो गया लैपटॉप का बोले मेरे पास है बोले
sorry for the interruption.
Yeah, so unsupervised learning would be where you don't know what exactly the output is, but still you want to make some sense out of the data that is available to you. And reinforcement learning is similar to how humans are being taught, that if you do something good, then you'll get a reward out of it. But if you do something bad, then you'll get a penalty. Like again, to give you more perspective on how things work in supervised learning, unsupervised, reinforcement. So supervised learning could be divided into regression and classification problem. So regression is usually when you predict something. For example, like you could be predicting cost of a house based on few features like what is the location of the house, or what is the area that the house, the square foot area of the house, or there could be like ample properties that eventually account to the cost of a house. So those predictions, or be it the revenue of a company, or be it a revenue of a movie that is being released. So all these predictions are being done just so we have a better understanding of, or we are better prepared maybe for the like outcome of any event. So that is what you can understand from regression. Similarly, classification is in your emails, you get this spam folder where the email gets automatically classified into whether it is a spam or it is not a spam. So there are times when it gets incorrectly classified, but most of the time Google does a pretty good job doing that for you. So it is not some like magic happening, but more like there is an algorithm running. That algorithm detects whether by a few keywords in the email, or if the email address is correct or not, or a lot of features at play that eventually detect that an email is a spam or not spam. Similarly, going to unsupervised learning. So, for example, when you open up Amazon and Amazon starts recommending things to you, or maybe when you are searching or browsing through the food ordering apps like Zomato, Swiggy, then they recommend food to you. So how does it actually happen? Or is it like they customize it for each and every customer? So that is not really the case. Instead, what happens is that there is user clustering being done as and when new users come up. And that clustering is based on behavioral properties like your age, or maybe gender, or the food items that you order, the food items, the cuisine of the food items that you tend to search for, and then even when you don't order. So like your entire behavior keeps on getting analyzed in the background, and based on that the clustering is done, and similar users are clubbed together, and then the recommendation systems work, and they show you different kinds of recommendations, and which match to your user personality. So that is what unsupervised learning does, because there is no output that is for sure available in the data, but it still runs, and it is still like clusters users into different groups, or maybe targeted marketing. So like when you browse Instagram, then there are ads that come up in your feed. So how are that ads shown up? So that is kind of targeted marketing, again based on your behavior, based on how you've interacted in different apps, how you've like what all things that you like in Google News, the stories specifically for you are shown based on your history, like what all stories you skipped, what all stories you opened. So a lot of data collection is being done, at the same time that data processing is being done, and then all that gets rendered for you. Similarly, for dimensionality reduction, so we have data sets available, but then if you don't have the computational power to process that data, those data sets, since those are like very big data, and that you have to process, and so you want to reduce that data into maybe smaller set of features, just the ones that are most important. So there the dimensionality reduction takes into action, and it reduces the features, but then at the same time it preserves all the context, or all the nuances of the data, or like the important information is not lost in that process. So there are algorithms that do dimensionality reduction for you. You can tweak them and apply it based on your own application that you're working on. But that comprises of so these all small subfields to overall comprise of what we talk about machine learning. Similarly, if you take example of reinforcement learning, so again, the games that you play where computer is opponent, so that is not really a dummy opponent. The computer knows how to play the game. So how does that happen? So basically, an agent is being trained by the rules of the game, and they are well versed with what would be that if they are in a particular state, then what is the state that will give you the maximum reward. That is why usually the computer opponents are pretty good, and even comparable or more than comparable to a human opponent. So So like those are the things that comprise of that eventually lead to what we keep calling that machine learning. Next, I would want to give a brief about what all natural language processing comprises of. So there are, again, like if you take example of Amazon, then when you see the reviews of a product, so you see that there are positive reviews, there are negative reviews, and then you can easily filter out positive, negative reviews. But like, is there a human being sitting and then tagging all those reviews into whether it is positive or it is negative? So no, not that is not the case. Instead, the machine itself can categorize a review into positive review and negative review. And it might seem like a very trivial thing that okay, if a sentence has good in it, then it would be like if a sentence has positive words in it, then it would be categorized into a positive feedback, and if it has some negative word, then it would be categorized as a negative feedback. But like, it's not that simple, because for example, like if you give a review about a movie that the movie was not that bad, so even when it has a negative word in it, it's actually a good review. So like the context of words in the sentence matters a lot. So so yeah, that is why even in sentiment analysis, or so these are complex problems that you have to deal with, or that most of, like, a lot of things have been already solved, but they are not that as trivial as it might sound. Similarly, things like machine translation, that is converting one language document into another language. So what Google Translate does it for you. If you open a website and then that website is in some other language, then it auto translates it in a few seconds to your preferred language. So how does that happen? Again, like if you convert from one language to another, it's not just about like word mapping, that if there is a word in this particular language, you will just map it to the other language. But there are words that have multiple meanings. For example, like if you take example of beer, then it would be like a tolerance capacity, or else it could be a toy. So like words which have multiple meanings, their appearances in a sentence would change entirely the meaning of the sentence. So all that has to be taken into consideration when we translate a sentence into another sentence. And there are word embeddings created, which kind of create a vector out of every word, and they have this embeddings which you can use for your purpose. But like, even then, it is a tough task to basically machine translate from one language to another. Or similarly, if you take example of information extraction, so if you when you search for a query in Google, and then Google lists so many web documents, or it just instantly answers your query, when actually it is browsing through, or it is scrolling through like so many web pages that are available over the internet. So how does it do that in so much less time? So that is how like, it is basically structuring of the information in the form of graph, so that the graph can so that you can traverse the graph easily and get to the answer of your query as fast as possible. So that is what information extraction does, that it crawls through all the web pages that are available, and then constructs a knowledge graph, which is kind of an entity relationship graph, and which helps you reach your query, the answer to your query faster. And also it allows you, for example, if you search for a Prime Minister of India, then you not just get the answer of who is the Prime Minister of India, but also a lot of details like where he was born, or a lot of details, more details about that particular person. So that is how knowledge graph comes in handy, because they have the entity that okay, the answer is Narendra Modi, and then you have to just fetch more details that are linked to that particular entity. So that is like huge data sets that have been created, and that keep getting updated as and when like at frequent intervals of time, just so the search engine can work and give you results in fraction of seconds. So yeah, similarly, if you see a question answering system like chatbots, that is also a tough, I would say, a tough problem to crack, because there are all sorts of questions that you can ask a chatbot, and then it should be aware of all that information. So for example, if you see a restaurant chatbot, then the restaurant chatbot should be you can ask questions like, what is the cuisine that the restaurant serves, or where is the restaurant located? So how does it interpret that where or restaurant or location? And then so there is also this entity recognition at play, which converts your sentence to their meaningful features, and then finds the answer to your query, and then responds you in a chatbot. So those are those all comprises of eventually to natural language processing. So so I guess that would be a brief introduction about all AI, ML, NLP that you keep on hearing about. If you have any questions, then please feel free to ask. Okay. So I'll just move on. So typically, how does an ML problem look like? And then what all are the, what to say, in industry or in academics, what is it that you keep on working on? So one thing is to define a problem as a machine learning problem. So not all problems can have a machine learning solution, but or not all problems, if solved by machine learning, would give you an optimal solution or the best solution. So the first step is to see whether a problem is actually a machine learning problem, or if it isn't, or if it can be solved by any other means, like a rule-based solution or any other solution. Then next step is to construct your data set. So now there are a lot of data sets that are already available, but even then, like for every problem, whenever the first research paper would have been written, then they would have constructed their own data set. So that is the first step, that you construct your own data set, but then that data set would comprise of like a lot of information, some of which might be of use to okay. Yes. So the first step was is to construct your data set, and then you need to transform that data set so that you have better features available, and you do refinement of the features. And if like the number of features are very high, then you try to reduce the dimensionality based on the computational power that you have or that you can use. And after that comes the part of like which model should I use and which model should I train, or how do I tweak the hyperparameters that are associated with the model that I'm training. And then the last step, which comes that, okay, once you've trained the model and your model is ready for being tested out, then you incorporate it in like whatever application that you are building that model for, and get the test data available, that how good is it running on the test data. So like on similar lines, in industry there are different designations, job designations available, that some of it works on one section, some of it works on another section. So I'll go through that also in some later part of the slides. So moving on. Now, what can you expect in academics that you can learn about, or that you can contribute in the research, or you'll be doing projects or assignments on? So in BTech, I took the course of neural networks and fuzzy logic that Amit Kalsar taught, which was where I got familiarized with this whole field, that what is artificial intelligence or what is machine learning. That was my starting point. But then when I did my master's, so there are a lot of advanced courses that are available that you can also learn about. I have jotted down the courses that I had taken, but I'll also give you some details on what all other courses are also available. So I took this Foundations of Machine Learning course, which was similar to what I had done in my bachelor's, which introduces you to what regression is, classification is, neural networks, then backpropagation, gradient descent, the algorithms that run, and then similarly decision trees. So that is the foundations course, and that is something that like anyone who wants to work in this field should be aware of, because even the companies and all, so we keep on learning about deep learning or recurrent neural networks and this and that, but companies usually see how well you are with the foundations. So this is one part that you should be like very well versed with if you are interested in contributing in some firm uh, in this particular domain. Similarly, the advanced machine learning course. So advanced machine learning was more about a deep learning, that is convolutional neural networks or recurrent neural networks, or how you should be training recurrent neural networks, question answering systems, or recommendation systems. So some of it is around case studies that already there is some recommendation system that exists, and then you learn about that how the layers are being trained, or how the layer, which part of it uses which RNN, or how many like hidden layers should be there in the recurrent neural network. So all those things, some part is around how you should be training, what are the algorithms that are available, and so on, what all advancements have been done in machine learning is what is taught in advanced machine learning. Then another course that I took was intelligent and learning agents. So that was about the gaming techniques, the gaming industry, that is reinforcement learning. So you have an agent and you have to train it so that it gives you the best result in a minimum time. So consider, for example, that there is one state, and that is the start state, and then you have to reach some goal, which is the end state. That maybe a football game that you are football agent that you are designing. So then your end result would be to make minimum penalties and then make a goal. So that is how you teach or train the agent, so that it gives you maximum reward and then gets minimum penalties. And also in that course, we were taught about this case study of Go game, which like even a documentary is available on AlphaGo. It is quite an interesting documentary because it shows you how the machine built agent was able to beat the human, the like champion available on in humans. So like you can see how competent the machine based agents can get over time if trained properly, and like a lot of advancement has been made, and that documentary shows it quite in detail. So yeah. Similarly, this organization of web information, which tells you about how search engines work, or how document filtering is done, or maybe how a word embedding gets created, that all the sentences that are available maybe in Wikipedia. So that is being used to train and get context of a word, and then a vector can be created out of that word, and you can use it in almost all natural language processing applications or use cases. So that is what I took these courses in my master's. And apart from this, this maths course I took, that was convex optimization, which teaches about all the algorithms and how the algorithms actually work. Like understanding the algorithm is one thing, but then why is it that the algorithm successfully works, or why is it that you get the minimum error if you are using that algorithm? So it was mostly around the maths associated with all these models that we talk about. But then there are other courses also that are available, like automatic speech recognition or computer vision related courses that you can take. And also like object recognition. So there are like ample courses that are available that you can choose from and learn about. Also, in most of these courses, you have a hands-on project and you have assignments that are also mostly implementing the algorithm that you are learning. So that goes hand in hand. So not just you are getting to know the theory about it, but you also get to implement it and see it working in like real world applications. So that is something that that is of more use, I would say. Moving on, about the industry opportunities. So as you see that there is one thing in a previous slide that I had shown, that this is constructing your data set and transforming the data, and then this is the training the model. So the data science, data analysts, or maybe quantitative researchers, so those mostly work on how the data is, how can you refine the data the best, and retain the important information and get rid of all the noise that is available in the data, be it through SQLite queries, or be it through maybe Excel, be it through Hadoop, which is for big data. There are like a lot of industry opportunities in the data section. Similarly for machine learning engineers, so once the data is being processed and is in a pretty good state, then you can come to thinking of models that can help you, that you can train, and that you can get the results that you are expecting out of that data, or whatever is the problem statement that you're trying to solve. And then comes a software engineer, whose role is to hook up. So now the model has been created, and now the model has to be applied in whatever product that you're working on, be it a web application or be it a mobile application. So that hooking up, that also needs that you should have some knowledge about what is the model, how does the model work, so that you can effectively use it. How can you tune that model if you're seeing any issues on your end. So all that aspects comes under software engineer. But the work that I just described, that varies across companies. So there are few companies who would maybe ask you to train models even when you have the designation of data scientist, or it could be vice versa. So it is a lot company specific, but on a broader level, I would say this is how the work is categorized. But how to prepare and how does the interview looks like? In that case, you would feel that, okay, coding will not be one of the judging criteria, but actually coding is, because that is how they get to know how logical do you think. And usually how the rounds go is there would be 3-4 rounds. First round would be where you would be given some coding problem, and you would be asked to solve that. Then second round would be where you get some objective type questions, which are which are some like multi MCQs type of questions, where they would ask you about the foundations of machine learning, like no deep learning, no reinforcement learning, nothing. It's only foundations that they expect you to know. So that you need to be very thorough with. Then the next round, which is usually like similar to how in software development you have this design around, where you are given a problem statement and you are asked to design like you are to come up with a design of how you'll implement that. Similarly, in machine learning interviews also, they ask you to design for a particular problem. So for example, they would say that, okay, suppose you are to build a recommendation system, how would you start with? So you cannot just jump to that I'll see whichever model fits best, and then I'll just run the data on that particular model. So you have to tell them that all the entire steps that are involved, that how you will gather the data, then how you will infer details out of that data, and then comes that, okay, how, after all that refinement that you've done, then which models will you try it out, and so on. So that was someone speaking? Okay. So that is what you can expect in the third round. And then the final round is usually the HR, or even if it is HR plus technical, so then they would ask you a little bit about machine learning related things, your projects, or maybe if you have a prior experience, or if you've done any hobby projects, or any courses that are available online, any certification you have, so that should also do good. So they would ask you questions about all those things also. So it matters if you are doing, or if you're planning to do some project, be it a hobby project, or be it anything. So it matters in the interview that you have some experience, you've built something on your own. So yeah, that would add on to your resume basically. In academics, one thing that I missed out was I'm not sure how many how many of you would be interested in PhDs, but there are like plenty opportunities available, where you would be working on state of art algorithms. You would be trying to improve upon the state of art, and you would get to publish research papers. That is something that you get to do in even in masters also. But yeah, so you will get pretty good problems to work on with pretty good professors. And so if you're planning for masters and you're not sure about PhD, then you can just enroll for masters, and at the end of masters program, if you feel that now you want to pursue PhD, then you can just extend it, and the PhD's coursework gets clubbed up with the masters 2 years, and you would just start off with the research for the next 3 years. But if you plan to get enrolled directly as a PhD student, then you can do that also. In the first 2 years, you will be doing coursework where you'll be taking up these courses. And post that, you can just start your research work. So that is what I would say is the difference between academics versus industry. That in industry, you may or may not work on state-of-art techniques, or like there, if a model is good enough, then it does not matter if you're getting 0.5% more accurate results by switching to some other algorithm. But when it comes to academics, then it matters if you are even improving 0.05% to the state of art. So yeah, that is one of the major difference that you would see in academics versus industry. So moving on, So about the skills that are needed, yeah, like language is needed would be Python and R, and then there are some data manipulation libraries like Pandas, NumPy. Like these are mostly those things that we used to work on when the assignments and all that were given to us in my master's. So I've listed down most of those, and those are the ones that are being used in industry also. Like scikit-learn or TensorFlow. So these are also libraries which have inbuilt machine learning APIs available basically. So for example, if you want to implement linear regression, then there would be an API available for linear regression. You can train it by tuning the parameters that the API exposes, and you don't have to write the linear regression algorithm on your own. That is the advantage that you get out of these libraries. And then based on, again, your use case, your application, you can train it, and also your data, you can train it and get the required results. Then another thing is this Jupyter Notebook. So that is not a must-have. It's just a kind of an add-on because it helps you to, like, if you want to try out something on a smaller data set and you don't want to code it or you don't want to change your main code, then you can just try it out on Jupyter Notebook and see if it is giving you results, your desired results, and then you can use the same in your main code. But like something that I would want to like emphasize, I can't emphasize enough, is mathematics. It's easier to just understand that, okay, there is this algorithm, you need to do this, and the algorithm gets trained. But the maths behind it is very, very important. And you just have to be like, you will be working with probability, statistics, linear algebra, matrices, vectors, and you should be like very comfortable with all these things, because if you are not, then you will know the algorithm, but you will never get to know as to if there is any change that you need to do to the algorithm so that it gets customized based on your use case or your scenario, then you will not be able to do that. So you just have to have a good foundation in mathematics is what I would say. And that is something that I feel most people miss out on, that they don't concentrate much on what is the maths behind, and they just understand that, okay, this is the algorithm, this is the input that you give, and you can just train it. But it is important, it is very important. Moving on, so if you feel like you are enough encouraged and you want to get more knowledge about these topics, and you want to build expertise in it, do some project so that they get listed out on your resume, then you can there are numerous courses that are available in Coursera, Udemy, on programming languages like Python and all, also, as well as on machine learning techniques, models, algorithms that are available. You can start off with any course, but don't just don't start off with a course in programming language, is what would be my suggestion, because all the machine learning courses that are mostly available, they have a project that runs side by side. You can start off with that project, and there is ample documentation available for Python or scikit-learn or anything and everything, and you can just go over those documentation as and when the need be. So you don't have to dedicatedly learn the programming language, but more like you should be learning about the maths and the algorithms that are available. Then another thing that we used to get our assignments on was Kaggle. So this has numerous problems listed out, and it is kind of competitions that are listed out there. A level of difficulty would be easy, medium, hard. So all sorts of, similar to how you have programming problems listed out on maybe HackerRank or Geeks for Geeks as easy, hard, medium. Similarly, these are listed out in Kaggle. You can pick any easy problem, then you can solve that problem on your own and submit the solution there, and you start seeing the test accuracy of your solution that you've posted. And then you can see other people too who have attempted that problem and their test accuracy too. So that way you get an understanding of whether your solution was actually an optimal solution or not, and is there a scope of improvement that you can do over your model. Yeah, like I personally liked a lot these Kaggle competitions, so you can maybe try that out. Yeah, I guess that was it from my side. If you have any questions or any thoughts, then please feel free to ask.
There are few in the chat box already for you.
Okay, I would say that so the demand in whether NLP is more in demand or ML is more in demand. So that depends a lot on what the company does basically. There could be like, for example, if you see Google, then Google works on NLP as well as machine learning. But if you see maybe similarly, like if you see Amazon, then Amazon will also be working on machine learning as well as NLP. So there is no like whether NLP is better or whether machine learning is better, but it should be more on your interest, I guess. You should maybe start off with the seeing what all NLP comprises of, and see if it actually interests you or not. If it does not, then probably you should explore more of ML. Okay, so about internship opportunities as a fresher, it might be a bit tough if you are aiming for a very like big organizations, but maybe few startups you can start considering. But then again, if you have no prior background, you've not done any project, and your understand I'm not sure how much you are what to say, how many courses you've taken in machine learning, what is your understanding about machine learning. So that all matters a lot, but it would be good if you are aiming for that you get an internship maybe 6 months later. Then you should work in those 6 months to do some hobby project, or like something that shows that you have a bit of understanding and you would be contributing in the internship that you do. So that is what usually companies see, that if you join them for a month or 2 months, then will you be able to contribute. So for that they definitely want to see some background, is what I would say. For applying, if you have some company in mind, then there are career portals in company websites themselves where you can just like see if there are internship opportunities available. That is one way to look out for. Another is LinkedIn. So you can see if you have any like alumni or maybe your seniors who are in some company that you're looking for internship. You can contact them. Or else there are HRs on LinkedIn who keep on posting information about that internship opportunities available in this particular company. So you should look out for those posts also. So that could help you. Okay. So no, you should. You can be. You need to be good at coding. That is for sure. But about data structures, it is okay if you are not. But coding is necessary, because see, even it's not like when you, even if you are coding in a Python, then also it is not the case that you can just like skip the coding part and just train the model, because you will have to write things like splitting the data set into maybe train data and test data, then feeding the train data into the model that you're creating. So coding will be an essential part of it. You cannot skip. uh, if you're not interested in mathematics, then should you try ML or not? You can definitely try. So the way I see it, it's like driving a car. If you don't know mathematics, car ride basically. So if you don't know mathematics, then you will probably be sitting next to the driver. But if you know mathematics, then you can drive it on your own. So that is how I see. But yeah, you can give it a try. You can skip maybe the what to say, the logic of why the algorithm works, and you can just emphasize on, okay, this is the algorithm, I can use it wherever my use case is, and on the basis of that you can go ahead. But yeah, if you feel that there is a need and if you develop enough interest, then do go over the mathematics also. Okay, should we expose to industry just after BTech, or should you do masters first? Again, that is a choice. But like if you, again, if in BTech you have taken enough courses and you have good knowledge, or like be it courses on campus or be it courses online, or you've gone over NPTEL lectures, then you can just start off and start working in the industry. You don't have to do masters, but I feel that at some point in time you would feel that there is a need to do masters, because to dig deeper into each and every domain, that is I'm not sure how much enthusiastic you would be to do it on your own, and masters just helps you do it by force, I would say. So yeah, is masters or PhD necessary to enter into data science field? So no, it's not mandatory to do masters or PhD. You can start off as bachelors also, but again, like you have to put in that effort. You cannot skip that effort of learning things, or of doing some even basic projects, like maybe movie revenue prediction, or maybe you can just get the IMDb data set and use that to do very basic thing, like very basic machine learning project, just to understand the entire flow, entire steps that machine learning, that solving a machine learning problem is about. So that knowledge is definitely important. So but yeah, a master's or PhD doing it being necessity, that is not the case. Okay, that would be a personal choice of whether you prefer online courses or you like learning from books, because there are ample books also available. There are ample online courses also available. So that is totally your interest, I would say. There are good books that are available. I can list them if you want to read, if you like are not able to find good books. But yeah, again, there is no preference in online courses versus books. It's your personal preference. Generally don't prefer. Okay, so it is not a myth, neither it is a fact. So what usually happens is that you may probably start off, you can start off as a fresher, but if there are people in your team who have done masters or who have done PhD, who have a more understanding or more in-depth knowledge on topics uh, that you would probably have a little bit less, because you've not gone through the 2 years or the 5 years that they've spent. So that could be one thing that usually makes it feel like, okay, companies don't prefer freshers or don't prefer just graduates for data science field. So you need to compete with those people. So if you are competent enough and you are comparable to those people, then it does not matter. But usually it happens that maybe one step up the ladder or two steps up the ladder, people tend to just go for masters or go for PhD and then gather more information in the field and then come back and join the company again. Now I'll start to publish a paper in machine learning. So if you want to publish a paper in machine learning, then first step would be to read a lot of papers. Like that is the starting point, and not just like any paper, but more like very the starting point of whatever topic that you are interested in publishing the paper. So you can start off with reading about research papers in that particular area. From the very start, that what all happened gradually, and that eventually led to this the state of art that is the state of art today. Because then only you know that what all paths have already been taken, and then you can come up with a new path or a new solution to a particular problem. Okay, I want to do masters and PhD in computer science. Whether to do it in India or in a foreign country, which will be good for my career options. Like I did my masters in India itself, and personally, I don't have like even that feeling that even like it was 0.001% also less, or if I have regrets that why did I do it in India and I should have done it abroad. That is so not the case. Like if you read about the professors in Indian institutions, you will get to know that they are like super brilliant, and they have worked on very tough problems, and they have published like many research papers. So they know, and they are specialized enough in their field. So if but still, again, like if you feel that like Indian institutes are will not guide you enough, or will not be a good journey for you, then you can definitely go for foreign universities also. There are ample courses in foreign universities too, which are like there are multiple departments available. Some institutes also have dedicated departments which are only for AI and ML, so you can aim for that also. Some have it clubbed up in computer science or else in electrical department. So you can browse the courses, you can see which university like which university you are interested in. You can read about the professors, their contributions, and their background research, what all fields that they work on, and based on that you can take the decision on whether you want to do it in India or in a foreign country.
So
okay, so first step, if you want to get into NLP, again, like like there are courses available which are of basic, intermediate and advanced levels. You can start with basic. You can at the same time in basic you would be taught about things like maybe entity recognition, or maybe how do you do a part of speech tagging, or how do you create an embedding out of the word, how do you convert the word into text when you feed it to a model. So those are the starting steps that you need to know before you get in-depth knowledge about what all NLP has to offer. So you can start building understanding around those things. If you want, again, I can find out courses that are like good, that can help you. I know that Professor Pushpak Bhattacharya from IIT Bombay, he has, I think, few online lectures also available, and he is into NLP. He has contributed a lot. If his lectures are available, for general public, then you can try and browse his lectures also. I'm sure it would be like they could be a good starting point. Okay, even if I okay, so being a mechanical student and not from CAS, will it be a barrier in my data science interviews, even if I have enough skills? So that is not the case. So see, companies don't really see that which department you were in, or in which department you did your bachelor's, or in which department you're doing your master's. That is never the case. If you are competent enough, and if you have enough knowledge compared to a CS guy, then you will definitely be picked over that person. So it does not matter if you did from which stream, but all that matters is that how much knowledge you have, and also that what all projects you've done, and are they like good enough. So that is important.
So we'll be taking up only last question now. Otherwise, it will remain an endless process, and our expert will be stretched for longer duration. They have already shut the door, so that means that it is going to be the end. And may I now request Mr. Chitresh, our student coordinator, to deliver the vote of thanks, a formal vote of thanks, and then we'll go on to close the session.
Am I visible, sir?
No, not as of now.
I turned on my camera, sir.
Okay, start speaking.
Yeah, I think I am visible, sir.
Okay, fine.
So every ending is just a beginning in disguise. The ending of this mesmerizing session marks the beginning of many new possibilities and knowledge about the number of worldly opportunities. On behalf of Office of Deal Alumni Affairs and Resource Generation of NIT Hamirpur, I seek pleasure in thanking you for your presence and giving us your precious time, ma'am. And we are all very inspired and grateful for the knowledge that you shared with us today. So without taking much more time, I would like to thank our administration, task team, management, and the audience to make this session a great success. It was an honor to have you. Thank you, ma'am.
Thank you, Smartika, and thank you all. Hope to avail your services again in future, and in person, physically over here in the campus. We extend our invitation to visit your alma mater once in near future, as soon as possible. Okay, so with that, we'll try to close the session. Thank you.
Thank you, sir.